And we can tell what local variables we have on our attributes by middle clicking on a node, and we can see we have custom variable mappings myvar. Now if I wanted to use this group, I could, for example, use a peak, set it to the group, and peak the points that are in that group. Let's turn that down a little bit. So only the selected points are being peaked. Peak, by the way, is an operation that moves a point or a primitive along its normal. We spoke earlier about how difficult it is to know whether a particular variable is available in a node. How do we tell then where we can use this variable that we've just created using the attribute create node? Well, fortunately there is some logic to it. Let's try now and put down a poly extrude. And let's try and use myvar to drive the extrusion. Well, we're not getting anything. And the reason for that is if we look at the help for poly extrude, we find that the local variables include PR, the primitive number, but they don't include PT, the point number. And this tells us that this node is a node which operates on primitives. And if it's a node that operates on primitives in general, variables that refer to point attributes, which is what we've got here, won't be recognized. So let's try turning this into a primitive attribute, and we can see that it is now recognized and we're getting the same chaotic result that we had earlier. Well, let's see whether or not we can use a primitive level attribute inside a node which is mainly looking at points. And I'm going to use the point sop for this. The point sop is something that allows us to change attributes on points, and I'm going to add, just for the sake of this example, an alpha value to our points, and I'm going to base it on myvar. And let's have a look now at the details view, and it looks like we've got a result. Well, that's because for a higher level variable or attribute, here we've got an attribute at the primitive level, this is recognized on nodes which are essentially working at the point level. And if we had a detail attribute, that would be recognized on nodes which work at the primitive level and at the point level. So there's a hierarchy here. A detail attribute or variable will be recognized at any of the lower levels. A primitive attribute or variable will be recognized at point and vertex level, point only at point level and vertex level, and so on. How do we tell that this node here is one that mainly operates on points, other than by looking at its name? Well, if we look at the help card, we'll see in the local variables that it has this local variable $pt, or pt rather, which is the point number, and that is a pretty strong clue that this is a node which operates mainly at the point level. A little bit more about what I mean when I say a node operates at the point or the primitive level. Well, some nodes operate just on all of the geometry at once. Other nodes are more like loops, or at least they can be thought of as loops, and this point node is one of them. And like any loop, they have an index, a variable which varies over each iteration of the loop. And in the case of the point SOP, that's $pt, the point number. So in effect, any expressions in the point SOP are being evaluated separately for each point, with the value of $pt being set to that point for each iteration. And of course, for a SOP that's operating on primitives, the equivalent would be $pr, the primitive number, which would change with each iteration. There are some occasions where you will get attributes on your geometry which you can't access using a local variable. Perhaps they've been created using a SOP, which some of the SOPs create attributes automatically. Perhaps they've been imported from a particle network or something like that. We can, however, still access the variables using a expression function. We can still access the attributes rather, not the variables. And the expression function depends on whether our attribute is a point, vertex, detail, primitive attribute, and so on. And there are 4 versions of this function, all more or less the same. I'm going to look at the prim function. The prim function is a function which grabs an attribute on a specific node and makes it available in an expression. So the first argument is the node, and that is going to be our attribute create node. Note that it's very important that you don't try to refer to the node in which you're actually writing the expression. You will get an error if you had put here .1, because the attributes for this node are not yet created, because we're still creating the node. So we have to use a node earlier on in the network. Okay, the next thing we need to give it is the primitive number that we're working on, and that is $pr. Then an attribute name. Well, it's called myvar. And then finally an attribute index. Now an attribute index is useful where a attribute has 3 components, for example, a vector, and then you would have components numbers 0, 1 and 2. In this case it's just a float, so our component number is going to be 0. And this is fetching our primitive attribute from our attribute create node and putting it into this expression. As we can see, the alpha values are still correctly being created. Now, there are different versions of this. There's a version point, and it's identical, except that, of course, you need to put in the point number. This is going to give us 0, because our attribute is not a point attribute, but a primitive attribute. And there's a version which is detail. The detail attribute, the detail function rather, doesn't take a point number at all, because there's only one detail. And let's just test that out by making our attribute a detail attribute. And of course we can't use the rand $pt if it's a detail attribute, so we'll have to use rand something which will create a value. It's 0.03. So here we can see that that's reflected in all our alpha values.